Section 3.4 and then also into 3.5, we're going to talk about two basic concepts. Concepts of algorithms and concepts of estimation. So algorithms just means a way of doing something. So like when you get up in the morning, you probably have an algorithm for how you get to class on time. And there's probably a set order that you follow, right? And if you're like me, if you don't follow your set order, you might forget something, like to brush your teeth or feed the dog. And it could be worse, right? But something like this. You've got an algorithm, a way in which you do something. There's multiple algorithms for how you could get ready in the morning, and they could all be effective for different people, right? So there's not always one way that always works for everybody, and that's what we're going to find out with addition and subtraction as well. Okay? Addition and subtraction today, 3.5 has multiplication and division. The first addition model that you usually work with kids on is called the concrete model. And what the concrete model does is it draws pictures. That's what it really does. Okay? So when you see the number 34, we're going to use the notation that we encountered back in, I think it was in section 3.1, where we were talking about longs and flats and blocks and units. Do you guys remember that? We're going to draw pictures using that kind of imagery. So when I see 34, I have 3 longs. Each of my 3 longs are 10 long because I'm working in base 10, okay? And then I have 4 units. So this is a concrete representation of the number 34. And then I'm adding to this the number 18. So here's 1 long, and now I have 8 units. Okay, so in some sense, here's one grouping of the number 34, and here's our second grouping of the number 18, and we are combining them together with addition. Now, the catch is that if we just draw another picture where we redraw all those elements, we end up with how many units? 12. Now, I don't know about you, but if somebody gives me back 12 pennies, I'm not especially happy about that, right? Or 12 $1 bills, not especially happy about that. Because there's a simpler way to give money back that would involve fewer coins or fewer bills. The same thing's true with our blocks in a concrete model. How many of those can I group together to make a bigger shape? 10. So I can take the 8 units here, for instance, and 2 more of these units, and I can trade them in for a long. So I've already got 4 longs in my picture, so my new picture will actually have 5 longs in it. And if you're actually using manipulatives with a child in a class, could they not really just stick these Legos together and make a long? Absolutely they could. They're actually called number cubes when you use them in a classroom like that. They're not called Legos, but you know what I mean. And then how many units do I have left? 2. And then we can count the result that we have left. What do we have? We have 52. 5 longs, 2 units is 52.
When you're doing like the actual manipulatives, is 5 one of the like flat square pieces or no?
No, it's one of the tiny little unit pieces, like it's tiny little bitty.
Big ones?
The big one's called a flat. It would be representing the number 100.
Okay, never mind.
Yeah, it would be the hundreds ones. All right, your standard algorithm. Your standard algorithm you know and love is going to take us like 2 seconds to do. Somebody walk me through, what do I do to add 34 plus 18?
Add 4 plus 84.
Okay, so Amy, we start on the right-hand side, don't we?
Yeah.
Does anybody think that feels a little bit awkward? I know you've been doing it all your life, but
Yeah, because we read left to right.
yeah, we read from left to right. That's a little bit weird that we're going to do math from right to left. A little weird. And when I add that together, Amy, what do I get?
You get 12.
12. And so I write down 12 like that, right?
Not exactly.
Not exactly.
I remember learning this kind of stuff, and it was so weird.
Yeah.
You take the 1 away.
Yep. So we put a 2 down here, right? And then we call this carrying, right? We carry the 1. So all of a sudden, the 10 that was a part of the number 12 become a 1. It's in the tens column, right? That's what really happened, yeah? So that's why there's a 1 in the tens column, is because I took 10 of something and regrouped it and I put it into a different column. Then I can add my 1, my 3, my 1, and I can get 5. So that's fine.
It is weird.
But it is weird. And for kids who are first learning it, it's even weirder. All right, I promise it is. I think I'm going to have to stop here. I don't really have time for the next one, so we'll pick up here next time.